Good evening, everyone. This is June 2018, Unit 6 of IAL Chemistry. I will discuss the questions which you have sent as a doubt. For question 1, because it is related to identification of the ion, so I will quickly go through this whole question. A compound of a D block element is dissolved in water to form a solution X. A series of tests is carried out on 1 cm³ portion of X. Record the color of solution X, yellow brown. So if it is yellow brown in color, what gives an idea? As I already mentioned, it is a transition element D block, so yellow brown solution, likely it will be iron 3 ion. Then solution X in a test tube added sodium hydroxide drop by drop, brown precipitate form which remain. So what are these formula of the precipitate? It will be iron 3 hydroxide. To 1 cm³ solution X in the test tube, add potassium iodide. Basically what happened, iodine itself, it is oxidized to iodine molecule and it will reduce this iron 3 into iron 2. So the color of the mixture in the test tube become darker. Why the color become darker? Because iodine molecule is formed. Iodine molecule, when it is formed, the formation of this brown solution is due to formation of iodine molecule. To 1 cm³ solution of X, added nitric acid followed by, so it is giving a white PPT and it confirm a chloride ion is there, so it means we add silver nitrate, AgNO3. You will write in words, I just wrote the formula here. 1 cm³ solution X, added sodium carbonate, so and the solution is acidic, so it will give fizz, bubbles, effervescence. Then part B, sulfur dioxide is passed to a sample of solution X. The redox reaction occurs in which sulfur dioxide turned into sulfate ion. So if sulfur dioxide is turned into sulfate ion, what is the change in oxidation number? Each oxygen is -2, so 2 oxygen will be -4. So sulfur should be +4. And here each oxygen is -2, so 4 oxygen will be -8, sulfur will be +6. So basically sulfur +4 changes to +6, so sulfur is oxidized. So other substance should be reduced. What is reduced? Because you can see it is no longer brown. So basically iodine molecule is reduced to iodine as well as iron 3 which was still there, some of the iron 3 which was still there when potassium iodide solution was added. Now that is also turned into iron 2. 1 cm³ solution Y in the test tube added an excess of dilute aqueous ammonia. So when we add dilute aqueous ammonia and we have iron 2 ion, so what we will observe here, dirty green precipitate, the color of the precipitate. Formula of the precipitate forms, so that is iron 2 hydroxide and cation which is present, that is iron 2. Leave the mixture. If we leave iron 2, iron 2 will be oxidized by oxygen present in air and it will turn into iron 3. The formula of the brown compound which is formed, so basically iron 2 is converted back into iron 3 hydroxide. Then complete the ionic equation for reaction of cation in solution X. So what happened, solution X was having iron 3, it was turning into iron 2. And if you want to balance in a redox equation, if you want to balance oxygen, we add water. If you want to balance hydrogen, we add protons, so there should be 4 protons. and the total charge, because the number of electron lost by one should be equal to number of electron gained by the other, the total charge must be balanced as well. So here plus 4 minus 2 and plus 2, so plus 2 minus 2 and plus 4, so net charge here, that is plus 4, and the number of the electron lost by one should be equal to number of electron gained by the other side. What will be the net charge here, the other side, when you check? So if I put 2, this will make 6 plus 6, because others are neutral. So I should put 2 here. 2 multiplied by 2, 4, plus 4 minus 2 plus 6, so that will be plus 6 as well. Next is question 2, part B. At what point in step 4 the time be recorded? Basically what we are doing, we are finding iodine thiosulfate type. This is iodine and propanol reaction, and then we 25 cm of solution of propanol, then sulfuric acid, then mixture of propanol and acid was added to iodine, and a clock started and a conical flask is shaken. After about 1 minute, 10 cm cube of reaction mixture was removed using the pipette fitted with pipette filler, and sample was run into a flask containing a solution. So that is to quench. So at what point in step 4 should the time be recorded? So at what time or at what moment the time should be recorded? So the step 4, which moment we should record the time? Basically when we transfer the solution, that moment we record the time. So when immediately when we transfer all the solution, or it is acceptable if you mention when half of the solution is being transferred to the quenching agent, because other half also it will take time. So you can both ways it is accepted, when completely it is transferred or half of the solution is transferred into a container having quenching agent. Next is question 2C. Calculate the concentration in mole per dm cube iodine solution immediately after mixing with acidified propanol at the start of the reaction. So original concentration of iodine, because this was the original concentration of iodine, but now what happened, we mixed with 25 cm cube solution of propanol, 25 cm cube of propanol and 25 cm cube of sulfuric acid. So total volume of a solution, originally it was 50 and the concentration of iodine was 0.02, but now the total solution is 100. So if the volume is doubled, what will happen to iodine concentration? The iodine concentration will divide by 2, because concentration is moles over volume. The number of the moles in 50 cm cube solution is same as number of mole in 100 cm cube. So relation between volume and concentration, it is inverse. So if we increase the volume, the concentration will decrease. So if originally it was 0.02, but now the total solution is 100 cm cube, so new concentration will be 0.01 mole per decimeter cube. The iodine present in 10 cm cube sample of reaction mixture after reacting for 70 seconds was titrated with 0.01 thiosulfate. Calculate the concentration of iodine in after 70 seconds, hence calculate the mean rate or average rate of iodine concentration. So what we'll do, we have the original concentration of the iodine, the moment when we mix, we have that concentration, and we will find the new concentration of iodine after 70 seconds, because basically here iodine which is present in the solution is reacting with thiosulfate. So using the moles and concentration, or using the volume and concentration, first we'll find the moles of thiosulfate. From moles of thiosulfate we'll get the moles of iodine which are present after 70 seconds. And to calculate the rate is a change in concentration divided by time. So original concentration of iodine when we mix, when it is mixed with other substances, minus the new concentration after 70 seconds and divided by time interval. So it is given in the question that we have concentration and volume. So moles equal, that will be moles of thiosulfate, concentration into volume 0.01 multiplied by 18.5 divided by 1000. So this will give us the moles of thiosulfate, which is in exponent 1.85 into 10 power minus 4. And from moles of thiosulfate, we'll use a ratio thiosulfate to iodine, 2 moles of thiosulfate, 1 mole of iodine. So 2:1 is the ratio. If we have 1.85 into 10 power minus 3, this will be x cross multiply. We'll get the moles of iodine, which is 9.25 into 10 power minus 5 moles. But if we need the concentration, to get the concentration, because the total volume of a solution is 100, these are the moles, so new concentration will be moles by volume. So 9.25 into 10 power minus 5 divided by volume of thiosulfate, volume of the solution. The volume here, it's 10 cm cube, because we only titrated 10 cm cube, so this should be 10, but that is in cm cube, so I have to divide by 1000 to convert into dm cube. This will give us 9.25 into 10 power minus 3 concentration. So this is the new concentration of iodine in the solution which is present, and originally we already worked out in the previous part that when the moment we mix, that was 0.01. So to get the rate, that will be 0.01 minus 9.25, because the rate is change in concentration divided by time interval, and the time interval is 70 seconds. So 0.01 divide minus 9.25 exponent minus 3 divided by 70 seconds. So this will give 1.07 into 10 power minus 5, and that's moles per dm cube second, because the concentration divided by volume. Next question. After 2C1 and 2. Question 3C1. Question 3C1. The voltmeter shows that the right hand half cell contain a positive electrode. Use information deduce whether potassium manganate 7 is a strong oxidizing agent, stronger than potassium and dichromate, and you explain how you made your deduction. So if it is strong oxidizing agent, it should gain electron. So if this is a positive terminal and the other one is negative terminal, so means electrons are lost from this side. In terms of loss of electron, this is anode, but in terms of movement of electron, this is negative terminal. So what is happening, actually chromium 3 is changing into chromium 6, and chromium 3 sulfate changes to potassium dichromate, like change in oxidation number of chromium 3 to 6. So when chromium 3 is changing into chromium 6, it is losing electrons. Electrons are all the electrode, like charges repel, so these electrons will move, and the Mn7 ion is there, Mn2 ion is also there. So that Mn7 ion can gain those electrons, and it is turning into Mn2. So it shows that this substance, it is reduced. If substance is reduced, it means it is a oxidizing agent, because the substance which reduction happened, that is oxidizing agent, or reduction means that substance is gaining electrons. So you will mention it is a strong oxidizing agent. Why? Because it is gaining electron which are lost from chromium ion. Then question 3F1 and 2. Standard electrode potential were measured for half cell, that is 1.51. Standard reduction potential for another system is plus 2. Aqueous sodium peroxide disulfate is a colorless solution contain S2O8. State all the observed color and any color change expect if a solution is added. So if solution is added, this reduction for Mn7 to Mn2 will be 1.5, and for S2O8 to gain electron turning into sulfate ion, the reduction potential is 2.01. When we compare the two systems, the one which is having higher positive, so it means that when reduction happen, another one is oxidized. So it means Mn7 will not reduce, basically Mn2 will turn into Mn7. So if we have a potassium manganate solution, that will not have any change because this substance cannot reduce manganate 7 as it is having a higher electrode potential or lower capability to reduce this manganate 7 to manganate 2, because when there's a mixture, it means Mn7 oxidation happen instead of, like Mn2 will oxidize to Mn7 instead of Mn7 reduced to Mn2. And manganese 2 sulfate, again manganese 2 sulfate is there, that will, if you have a manganese 2 sulfate, that substance will be oxidized. Here there will be no no visible color change. The solution will remain as it is, like purple due to Mn7 ion. But here Mn7 will change into Mn2 because the reduction potential is 1.5. So for this one, Mn2 will oxidize to Mn7, and the color Mn2 is colorless and Mn7 is purple. So color change from colorless to purple. Question 4a. Salicylic acid is the original name of a compound which can be obtained from bark of willow trees. Systematic name for this salicylic acid is 2-hydroxy benzoic acid. Give a simple chemical test which is positive for 2-hydroxy benzoic acid but not for benzoic acid. Like, it should not be a test for acid, it should be a test. Basically, if it is not test for acid, then what it should be a test, it should be a test which confirm the presence of benzene ring. So we just have to write a test for benzene ring. How we can test a benzene ring? So for test for benzene ring, we can add ethynyl chloride, and this will result, because ester will form, so this will result steamy fume due to HCl, and characteristic smell it will be there due to formation of ester. Or you can also add iron 3 chloride, and the color will change for the solution. Or you can also add bromine, then it will give white precipitate, and the bromine itself will be decolorized. So these are the doubts related to June 2018 Unit 6 of IEL.